Welcome to The Explainer. Today, we're diving into something that's, well, absolutely critical for any web developer: security. It's easy to think that if your app has a login page, you're all set, you're safe. But what if I told you that a simple login is really just the welcome mat in front of a house with all its doors and windows thrown wide open? So let's just ask that question right out of the gate. Is that login page really enough to secure your application? I mean, if you're building something, you've probably put in a way for users to sign in. But does that actually protect them and you from all the crazy sophisticated threats out there today? The answer, and it's a big one, is a hard no. That's because behind that seemingly safe login screen, all sorts of threats are just waiting to pounce. We're talking about really nasty stuff like cross-site scripting and cross-site request forgery, where attackers can literally hijack a user's session. We're talking about unauthorized people getting their hands on sensitive data, weak passwords getting cracked in a heartbeat, and, of course, the constant fear of a major data breach. A simple username and password check, it just doesn't stand a chance against these modern attacks. But hey, don't worry, this isn't all doom and gloom, because there is a hero in the Java world that was built to handle exactly these kinds of problems. And that's where we bring in Spring Security. It's a powerhouse of a framework that gives you multi-layered protection. Okay, so let's get into it. What is Spring Security really? Well, at its heart, it's a super powerful and highly customizable framework for handling, well, who gets in and what they can do. Think of it as your application's own digital guardian. It's a core part of the whole Spring ecosystem, and it's designed from the ground up to protect you from unauthorized access and common breaches right out of the box. Now, to really get a handle on how Spring Security works its magic, you first have to understand the two fundamental pillars of any modern security system. And those are authentication and authorization. Seriously, getting the difference between these two is probably the single most important step to building something that's genuinely secure. So let's break this down, because it's a point of confusion for so many people. Think of it like this. Authentication is all about answering the question, who are you? It's the act of verifying someone's identity. A perfect example is a student logging into a school's website with their username and password. The system says, yep, you're you. Now, authorization asks a totally different question. Okay, but what are you allowed to do? So once that student is logged in, authorization kicks in. It determines their permissions. Sure, they can view their courses, but there's no way they can create new ones. So one is about identity, the other is about permission. So now that we get the what, let's talk about the how. Spring Security isn't just some abstract idea. It's a real, practical toolkit. It comes packed with essential features that you can use right away to seriously lock down your application. Let's start with what has to be the #1 rule of security. You never, ever, ever store passwords in plain text. Seeing a password like mysecret123 just sitting in a database, well, it's a developer's absolute worst nightmare. Because if that database gets breached, and let's be real, breaches happen all the time, every single one of your users' passwords is just out there for the taking. And this is exactly where password hashing comes to the rescue. Instead of storing the password itself, you store this scrambled, totally unrecognizable version of it called a hash. So that simple mysecret123 gets transformed into this long string of what looks like complete gibberish. And here's the magic. This is a one-way street. You cannot reverse engineer the original password from that hash. It's impossible. So why is this so critical? Well, with hashing, the actual passwords are never stored in plain text. This protects your user's credentials even if your database gets completely compromised. Spring Security even uses advanced techniques like salting, which means it adds a little bit of unique random data to each password before hashing it, making every single hash unique. And you know what the best part is? It makes this super complex process really easy to use with a tool called bcrypt password encoder. All right, let's talk about one of those acronyms that sounds way scarier than it is. CSRF, which stands for cross-site request forgery. All this really is, in simple terms, is an attack that tricks a logged-in user into accidentally sending a malicious request to a website they trust, without them even knowing it's happening. So, here's how an attacker could pull this off. Step 1. You log into a trusted website. Let's say your online bank. Step 2, you're still logged in, but you open another tab and visit a malicious website, maybe one you clicked on from a phishing email.
Step 3. Now, that malicious site in the background secretly forges and sends a request to your bank, something like transfer funds. And because your browser knows you're already logged in, the bank thinks the request is legit, and it came from you.
Spring Security's defense against this is just so smart and effective. It's called the CSRF token. Think of it like a unique secret handshake. It's a random value that Spring Security generates just for your session. Now, for any important action, like transferring funds, the application demands that this secret token is sent along with the request. The bad guy's website? It has no idea what that secret handshake is, so its forged request gets blocked, flat out. Okay, so we've got our user authenticated, and we're protecting them from forgeries. But we still need to manage what they're actually allowed to do. This is where our next tool comes in, and it's called Role-Based Access Control, or RBAC for short. It's just a really clean, simple, and scalable way to manage permissions. Let's go back to our learning management system. Instead of trying to give permissions to every single user, one by one, which would be a nightmare, you just create roles. You might have an admin role that can do basically everything. Then you've got an instructor role. They can create and edit courses, manage their own students. And then you have the student role, who can only view the courses they're assigned to and submit their work. See how clean that is? It keeps everything simple and secure. All right, let's do a quick recap of the big takeaways here. First, and most importantly, security is so much more than just a login page. Second, remember those two pillars. Authentication is all about confirming who you are, and authorization is about deciding what you can do. Third, Spring Security gives you these crucial tools like password hashing and CSRF protection right out of the box. And finally, using role-based access control, or RBSE, is going to make your life so much easier when it comes to managing permissions. And that brings us to a final thought to leave you with. It's pretty easy to put a lock on the front door of your application. But real, solid security is about knowing who holds all the different keys to all the different rooms and why they have them. It's about building a system that isn't just locked, but is intelligently and securely managed from the inside out. Thanks for joining us on The Explainer.